All right, we've got an airplane flying, and it's going to end up flying directly over some observer. So let's go ahead and sketch this. We've got our plane, and it's flying at some given altitude. It's going to go directly over an observer. And the observer is looking at this plane, and there's a certain angle of elevation, call it theta. Okay. So, and of course this plane is at an altitude of 10,000 feet. And we're looking for the speed of the airplane, so we can think of that as how fast this distance is changing. So let's talk about some information that we know. First of all, we know that at a given instant, theta is 60 degrees, and we can multiply by pi over 180 to turn that into radians. So we'll do that. That's pi over 3. And we also know that d theta dt at that moment is 1 degree per second. And so again, we can multiply that by pi over 180 to get that in terms of radians. All right, and we're looking for dx dt. Well, we have a relationship. We've got a triangle. We have an angle. We have the side opposite, and we have the side adjacent to it. So we can use the tangent of theta equal to 10,000 over x. And now we can take the derivative. So the derivative of tangent theta is secant squared theta times d theta dt. And then the derivative here will be negative 10,000 over x squared times dx dt. Well, we can plug in what we know. We know theta, so we have a secant squared of pi over 3. We know d theta dt is pi over 180. Negative 10,000. We don't quite know x yet, but we can find it. And then dx dt, of course, is the thing we're looking for. So let's talk about finding x. We have this relationship that tangent theta equals 10,000 over x, and we happen to know theta. So we'll come over here and say, well, tangent of theta, which is pi over 3, equals 10,000 over x. Okay, so x is equal to 10,000 over tangent of pi over 3. And tangent of pi over 3 is the square root of 3. So there's our x. All right, secant of pi over 3 is 2, and so we're squaring that, so we got 4. So 4 pi over 180. We can multiply by x squared over negative 10,000 to get our dx dt. And we can go ahead and plug in the x that we have. So we've got negative 4 pi 10,000 squared over square root of 3 squared, which is just 3. And then we've got the 180 and the 10,000. And all kinds of stuff simplifies here. So one of the 10,000s will cancel. 4 over 180 is 1 over 45. So we end up with a, let's see, a 10,000 pi negative over 3 times 45, which is 135. Let's go ahead and plug that in to get an idea of what's happening here. So we have 10,000 times pi divided by 135. So 232 This is approximately 232.7. And this is in feet per second. Of course, it's negative there just because we labeled it as the distance from there to there, which is decreasing.